Section 5.7, the Pythagorean Theorem. Want to do a quick review from an algebra concept about simplest radical form, and I've been using it in class. I've had it in a video or two, but I want to talk about it right here in our first example. Find the value of x. So by the Pythagorean theorem, we know that x is going to be equal to the square root of 2 squared plus 6 squared. So this gives us 4, this gives us 36, so we have the square root of 40. Now in order to get that into simplest radical form, what we want to do is we want to find a perfect square factor. A number that divides 40, but is also a perfect square. So we're looking at 4, 9, 16, 25, 36, and so on, because this is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So a perfect square factor, something we can pull out of the 40 and take the square root of evenly. So that's going to be 4. So 40 we can break up into the square root of 4 and the square root of 10. Because 4 times 10 is 40. Root 4 times root 10 is root 40. Now the 4 we can take the square root of to get 2. And now we put everything back together into 2 root 10. So these two numbers here are equivalent. If you plug this into the calculator, plug this into the calculator, you will get the same thing. But it's a simplest radical form. It's a format that we need to know about. Now when simplest radical form is not required, that means all 3 sides are whole numbers. When all 3 sides of a triangle are whole numbers, and that triangle is right, so all 3 sides of a right triangle are whole numbers, that's what we call a Pythagorean triple. A squared plus b squared equals c squared, and they're all whole values. Now we've been talking about side lengths to determine a triangle. You know, the 2 smallest sides have to add up to more than the third. Now that tells you whether a triangle can or cannot exist. What we're going to look at now is not only can the triangle exist or not, but what type of triangle would it be? So we can use the Pythagorean theorem and the idea about inequalities in triangles to make this determination. We can figure out whether a triangle is acute, obtuse, or right based upon the Pythagorean inequalities theorem. All right, think about a right triangle. Okay? A squared plus b squared equals c squared. Well, take c and extend it. So now it's longer. Well, what's going to happen is that A is going to have to shift over in order to meet C at its new endpoint. And when A shifts over, our right angle becomes larger and becomes obtuse. So if C squared is greater than A squared plus B squared, the hypotenuse got longer, which means our right angle got larger. It is now an obtuse triangle. Conversely, if C shrinks down, that means A is going to move over to meet it. Our right angle is going to get smaller. So when C squared is less than A squared plus B squared, we have an acute triangle. So tell whether the following sets of side lengths can form a triangle. If so, classify it. So first, let's see if this can form a triangle. So 5 plus 7, is that greater than 10? This is from a previous section. 5 plus 7 gives you 12. 12 is greater than 10. That checks out. This would form a triangle. So now here's the next part. What type of triangle would it be? We'll take the 2 shortest sides, squared and summed, and compare them to the third side squared. Now if these equal each other, it would be a right triangle, because that's the Pythagorean theorem. A squared plus b squared equals c squared. However, if this side is larger, that means the hypotenuse got larger, the right angle got larger, it's obtuse. If this side is smaller, that means the hypotenuse got smaller, the right angle got smaller, and it's acute. So let's see what happens. We have 25 and 49 compared to 100. That gives us 74, which is less than 100. So the hypotenuse got bigger. It's bigger than the other two sides squared and summed. That means the right angle got bigger. So the triangle is obtuse. So for the remainder of these examples, go through this two-step process. Does it form a triangle? If it doesn't, you're done. Hooray! If it does, go on to this next step. What type of triangle would it form?